Well, hello there. Sion Batson here from Sion Batson Tutoring, and in this video we will be solving systems of equations using the substitution method. A very important concept for all of my 8th graders and all of my students taking the Algebra 1 regions, the Algebra 2 regions, the Geometry regions, the GED exam, and even my first year college students. This video is for you. So, join me. Now, we can use the substitution method to solve a system of equations if one of the variables in the system is isolated or on a side by itself. I will repeat that. We can use the substitution method to solve a system of equations if one of the variables in the system is isolated or on a side by itself. Now, in some systems, you will have to isolate one of the variables. In other systems, one of the variables will be isolated for you. In this video, we will be solving systems that have one of the variables already isolated. So, join me. Now, in our first system here, we have y is equal to negative 3x plus 5, and the second equation says 5x minus 4y is equal to negative 3. Now, we can use the substitution method to solve this system because the y in the first equation is isolated, or the y in the first equation is by itself. Yes? Now, when we use the substitution method, all we will be doing is substituting to solve for the variables. Let me show you what I'm talking about. Now, in the first equation again, we know that y is equal to negative 3x plus 5. Now, in other words, y is negative 3x plus 5. Yes, y is equal to negative 3x plus 5 simply means y is negative 3x plus 5. So guess what? Because we know that y is negative 3x plus 5, in the second equation here, we can replace this y with negative 3x plus 5. Why? Because the first equation tells us that y is equal to negative 3x plus 5. Make sense? So that would be our first step. Our first step to substitute or replace this y with negative 3x plus 5. So in the very first step, we will substitute. Yeah? And if we substitute a negative 3x plus 5 for this y, we will get 5x minus 4. And then I'll replace the y now with negative 3x plus 5. And that's equal to negative 3. So the first step will always be to substitute. Yes? Now, after we substitute, the next step will be to get rid of the parentheses. Now, if you look at our equation now, we have just x's. We have an x here and an x here. Now we will solve for x. Yes? So after we substitute, we will remove the parentheses by using the distributive property. Yeah? And when we use the distributive property, we will multiply this negative 4 or whatever number is outside of the parentheses by all of the terms that are inside of the parentheses. So we'll multiply negative 4 by negative 3x, then negative 4 by positive 5. So negative 4 times negative 3x is positive 12x, and negative 4 times positive 5 is negative 20. Then we put back the terms that were there before. Yes? So we first substitute, then we distribute. Now, if you look, we can simplify this equation here by combining the like terms. We have an x term here, and we have an x term here. So we'll combine the like terms. If we combine the like terms, we get what? 5x plus 12x is 17x. Then we have what's left. Minus 20 is equal to negative 3. Yes? Now, we're not done. We still have x. We're solving for x. Yeah? So we'll do what? We add 20 here. add 20 here. And then we're left with what? This minus 20 plus 20 will give us 0. So we're left with 17x is equal to 17. Yeah? And the last step will be to get rid of the 17. 17 divided by 17 is 1. So we have 1x there. And then we divide this out by 17 as well. So x is equal to 17 divided by 17 is 1. So we have successfully solved for x. Yes? Now, we're not done, however. This system has two variables. We have a y and an x. We've successfully solved for x. Now, let's solve for y. How are we going to solve for y? Well, the first equation tells us that y is equal to negative 3x plus 5. Yes? Well, now that we know that x is equal to 1, we can replace this x with 1, or we can substitute this one for x and find y. Yeah? So let's do it. Y will be equal to negative 3, and we will replace that x with 1 plus 5. So y is equal to negative 3 times 1 is negative 3 plus 5. Y is equal to 2. How was that? Wasn't bad, right? So we have successfully solved for both variables. X is equal to 1 and y is equal to 2. So the solutions for this system will be x is equal to 1 and y is equal to 2. That's it. Yeah? Very simple, right? Very fun. Key note to remember is once one of the variables in the system is isolated, we can always use the substitution method to solve the system. Yeah? Remember the steps. We will first substitute, then we'll use the distributive property to get rid of the parentheses, then we'll combine the like terms, then the last step will be to solve the equation. Yeah? Let's put solve. So at least you have some order and a few steps that will help you solve. Yeah? Substitute, distribute, combine, solve. How is that? Now, let's work one more. So what I'm going to do now, I am going to ask you to try this one on your own. Yes? I'm going to put a new system on the board. And what I want you to do is to try it on your own. So what you can do for me is pause the video. Yeah? Pause this video and try this one in your notebooks first. Then come back and see if we get the same answer. Yeah? Give it a try. If you have to go back and watch the first example, pay attention to every step. Yeah? Then come back and try this one on your own. It's very simple. Simple and fun. You can do it. Don't let all the variables and integers overwhelm you. Go step by step, and I can guarantee you, you will master this concept. Okay? So pause the video and try it, then come back. Now, welcome back. Let's see if we get the same answers. So again, we can use the substitution method to solve this system because the y in the second equation is isolated or by itself. And remember, that's always our clue. We can use the substitution method to solve any system if one of the variables in the system is isolated. So here, the y is isolated. Y is equal to negative 5x minus 17. Or y is negative 5x minus 17. So because we know that y is negative 5x minus 17, we can replace this y in the first equation with minus 5x minus 17. Why? Because y is minus 5x minus 17. So our first step would be to, do you guys remember what the first step is? Substitute. We'll substitute negative 5x minus 17 for y, or we will replace this y with minus 5x minus 17. So let's substitute. If we substitute, we'll have negative 3x minus 3. I'll change the ink just so you can get a better picture of what's happening here. Yeah, this is fun stuff. It's fun stuff. So the first step is to substitute. Once we substitute now, you will realize that the equation has just one variable now, just the x. So we'll solve for the x. Yeah. So the next step will be to get rid of the parentheses. And to get rid of the parentheses, we will use the distributive property. And when we use the distributive property, we'll multiply the term that's outside of the parentheses by all of the terms that are inside of the parentheses. So let's distribute. Minus 3x times minus 5x is positive 15x. Yeah, positive 15x. And then minus 3 times minus 17 is positive 51. Then we'll put back what's left we have, or what was there before. We did so far so good. So after we used the distributive property, we left with minus 3x plus 15x plus 51 is equal to 3. What's next? We can now combine our like terms. Right? We have an x term here and an x term here. Minus 3x plus 15x will give us 12x. So once we combine our like terms, we will put back the rest of the terms. Now we can solve. Once we've combined, we will solve. I put solve in red. I don't know. I just like using different inks, just so you can get a better picture, see better what is going on. Yeah. So the first step here will be to what? Take 51 from both sides. Yeah. So 12x is equal to negative 48. Yeah. And then we will divide both sides by 12. 12 divided by 12 is 1. So we have just 1x there. And a minus 48 divided by 12 is negative 3. So we have successfully solved for, sorry, 4. Oh my God. Negative 4, sorry. Yeah. Negative 48 divided by 12 is negative 4. We all make mistakes, yeah? Okay, so we have successfully solved for x. Now we will do what? Solve for y. Students always make the mistake of thinking, well, I got x, I'm done. No. The system has two variables, x and y. So we have to solve for both variables. We have x. Let's solve for y. The second equation tells us that y is equal to negative 5x take 17. Yeah? Now that we know that x is negative 4, we can replace this x with negative 4 because x is negative 4. Yes? So let's replace this x with negative 4, or let's substitute negative 4 for this x. Yeah? So let's do it. Y is equal to negative 5. Let's put our negative 4 here in red so you guys can see that we substituted that. Yes? What's left? Then we have y is now equal to negative 5 times negative 4 is positive 20. And we have the negative 17 here. Let's put a negative 17. All right. So y is now equal to 20 minus 17 is 3. So look at that. We have successfully used the substitution method to find the values of both variables in the system. X is negative 4, y is 3. So the solution to our system is, let's put it in red. X is negative 4 and y is 3. How was that? I hope you guys got the same values for the variables. If you did not, don't panic. Don't get overwhelmed. Don't get angry. Don't get frustrated. That's fine. Right? Just go back, find your mistake. Yeah? Understand why you made that mistake and fix it. And you can watch the video as much as you want to and practice. I would advise you to watch the first example. Yeah? Make sure you understand the concept properly. Then try the second system on your own. And try it as many times as you want until you master the concept. Yes? I really hope you guys enjoyed this video. I really hope you will find it useful. Until next time, enjoy your math homework and remember to practice. Thank you.